Hi friends, today we are going to see demo on Snowflake table stream and how we can use that stream for auditing purpose. If you have not seen my recent blog on Snowflake stream, I would suggest you to please have a look. I had captured complete detail there. You can find my blog link in video description below. So before we start with the demo, let's understand briefly what is stream. Stream is an object, Snowflake object, which captures DML operation on a table, including metadata about each changes. This process is also known as change data capture. Let's see more detail on the demo. So when we say how we can use stream as a auditing capabilities is basically I wanted to say as we are tracking all the changes, all the DML operation on a particular table, that those changes can be very smartly used as a for auditing purpose. So say we have any table, and if we want to track each changes on that table and populate the audit table for any kind of for auditing purpose or for any kind of future reference purpose, we can easily achieve those goals with the user stream. And today I'm also going to show a small glimpse of task. Basically task is nothing other than scheduler. So basically in Snowflake, if you want to schedule anything, if you want to execute something on a scheduled time or on continuous basis, you can use task. And today I'm going to showcase you how you can use the stream for auditing purpose along with task. So let's start with the demo. And today I'm going to use the sysadmin as always. I'm going to create a new database called stream audit demo, and I'm going to create a new table for this demo. I'm going to create a table called employee, and this table will only contain the employee ID, which is basically mentioned as ID column, and the name of the employee. And I'm going to create a standard stream on employee table so that I can easily track all the DML operation, which is insert, update, and delete. So as of now, you can see that I'm not able to see any record on standard stream because we have not done any kind of a DML operation. So there's nothing on the stream. So that's we already know, nothing new. Now I'm going to insert 6 records, basically 6 employee in the employee table. So you can see that there are 6 employees and it successfully inserted all the 6 rows. Now if we go and first let's query the main table, and then we will query the other table. So let's copy this and paste it here. Let's see whether we have 6 records in the table. So you can just see that we have 6 records in the table, and I'm expecting all the same 6 rows as the insert statement in the stream as well. So you can see we have 6 insert statement. Action as a action is insert, and update is false. That means it's all an insert, and all the 6 rows are mentioned over here. So now till now we are good, and we have tracked easily all the rows. Whatever we have inserted, all has been tracked in the stream. But now stream is a temporary object, right? The moment you will start consume the stream, or you do a commit along with the DML operation, this stream is going to be truncated. So it's not a consistent storage, right? So we have to understand that once we consume the stream in a DML operation followed by a commit, the stream will get truncated, and then it will be kept for future tracking. So all the other future tracking on the base table can be tracked under the stream, but the data once consumed will not ever will get be referenced on the stream. So what we can do to track those table as a consistently, so what we can do is we can create a replica table of employee. We can name them as an audit table or whatever we want, and then we can read all the tracking details from the stream and let them insert into the audit history table. So before doing that, let's do some kind of DML operation apart from insert. So I'm going to update the employee table with the name as Lucy, where ID is 1. So earlier the value of Lucy was one was Lucy, and now I'm going to update the name with Lucy. And I'm going to delete one employee. Maybe he left the organization, so I'm just deleting one record where the ID is 6. So now that I have deleted, I'm assuming I have in employee table I have 5 rows. So correct, we have 5 rows. That's the delta effect. And as I have updated the name, we can also see the same on the stream. That there also we have the 5 rows with one record updated with Lucy. Correct, because we have not consumed, we will not see the 2 rows for that update statement. If you have followed my previous demo, you will understand this part. If you have not followed, let me repeat that. Unless you consumed your stream, your stream is a temporary area of storage, right? So not storage, basically your stream is a temporary place where or you can say the temporary memory area where all your tracking is being stored. So if you insert something and then if you delete, you will see the delta impact of that record not being inserted into the tracking table. And if you update, you will see the final updated value of those record as an insert rather than insert and delete. So now that we are clear, so we now till now we have seen that we are seeing the proper data on the stream table. Now let's query again the standard table. Yes, so we can see the same data. Now what I'm going to do, as I suggested, I'm going to create a employee audit history table because I want to keep this tracking history into one persistent table which can be used in the future for my auditing purpose, right? So if auditor come and ask me who did what on this particular table, I don't have anything. So if I create this, I can easily show them, okay, this is the audit history, right? So you can go ahead and see and who did what or at what time, what action was performed, that is tracked under this. So what I'm going to do, I am going to create a replica of the employee table, and I am going to create an additional column known as record version and record date. So basically I want to track 3 different things: stream type, which stream inserted this record, what was the record version, so and the record date. So basically what time this history track record was created. So how we are going to populate, we will see on the below where I have written one query which will track all the history. So now I'm going to update again the employee name of ID1 into K Lucy from L Lucy. So I updated that. What I'm going to do is now, as I said, like this demo will also include a glimpse of small task. So this is task. So how you create a task is basically you can create task name. You have to provide the warehouse which we are going to use for this task to run. Basically the scheduler, it's nothing else than scheduler, which sits on top of a select statement or an SQL statement, which will get executed based on the schedule you design. So schedule I have provided you equal to 1 minute, and basically this task will look into the system.stream has data, and then I'm going to pass the name of the stream which I just created on the top. So you can see that the name of the stream was standard stream, and I provided on the stream, and this is the system function which basically look into the standard stream and give the information that whether stream has any data or not. If stream has data, even if this task keeps on executing, and if stream doesn't have data, it will skip to execute this select statement or the merge statement or whatever SQL statement we have provided after the as clause. So what my merge statement is doing is, my merge statement is going to merge all the records in the employee audit history table while it will look or it will use the select statement. It will look into the SQL statement which is being created out of standard stream. So basically I'm using the standard stream table as a input or the source for my employee audit history population. So what I'm going to look is, I'm going to look into the standard stream, and I'm going to look into the ID column. I'm going to match the ID column, and this scenario is only true in case my stream table metadata action table is delete. So in case of delete action, I'm going to look when ID is matched and when action is delete. So if data is matched and metadata is update is false, that means it is a pure delete statement, not an update statement. Then just update the record version to 9999 and update the stream type as delete. Okay, and because if you know how the stream behave is basically when you delete a record, it also create a record with delete action, and in case of update also it create two record, one with insert, one with delete, right? To mitigate those differentiation, whether it's a delete or an delete because of update, we have done this clause where I am matching the delete action and also the ID, but I'm then segregating the version methodology based on the metadata is update. So metadata is update is the column which differentiate between the actual delete and the delete created out of the update statement. So if the update is action, update is metadata is update column is false, that means it's a pure delete. So I am just creating a updating the record with version 999 and stream type as delete. But in case it's true, that means it is created out of the update statement. I am doing the update of the revision with current revision -1. Okay, and when nothing match, basically that if it's not a delete statement in case of update or in case of normal delete, it's a insert statement, right? So what I'm doing, I'm just inserting all the data. Basically action will also give you the insert statement only, and with the current timestamp and the revision with 0, which indicate this is a fresh insert statement. And for the update statement, it will be current revision, because if it's an update, that means you already have a record, right? So I'm going to use the current revision version -1. And in case of delete, I'm just going to provide the default value of 999, which indicates it's a delete statement. So let me create this task, and to brief you out about task, when you create a task, it is always created on the suspend mode, so that it's not started by default, and it will get started only when you alter the stream to get it started. So let's first show whether we have created task or not successfully. So you can see that if you use the show task, it will list down all the tasks in your schema with the status and all the other details which you want to see. And if you look on the state column, it will be mentioned as a suspended, and it will also give you the definition. If you click here, you will see the definition of your task. So what your task is going to do, so basically now you know that your task is being created, but it is on suspended mode, so it is not running. But to make the task in the active mode or the start mode, you have to alter the task and make it resume. But either you need a privilege to do that, or you can use the account admin. So what I'm going to do, I'm going to use the role account admin, and first I'm going to give the execute task on the account level to role sysadmin, because that's my default role, and then I'm going to resume the task so that it automatically start populating the employee audit history table, and then we will see further details, right? So first let me see that do we see any kind of a data on audit history, because we have not done anything. So okay, I think we have not created the audit history table or what. Let me see quickly. Okay, so I forgot to create the audit history table. Now you can see that I have created audit history table. Let's query this. So as we have just created, there is no data, right? So sorry, there is no point of executing. Let me connect with the or change the role to account admin, grant the execute task, because without execute task, you maybe if you have even created the task, but if you start the task, your task will fail. So now what I'm going to do, I'm going to get the grant execute task, and I'm going to alter the task and convert that from the state of suspended to resume. Let's do that. So now that I already did whatever is required, um, I'm going to use my role sysadmin, and I'm going to see on the employee table how much record is there. So we can see there are 5 rows. In employee audit history there is no data, but if we query on the standard stream we will see 5 rows. So we can see these are the 5 rows with the latest update. And if we query, keep on querying some time, after 1 minute you will see that the stream is blank. So let's wait for 1 minute or so, and then we will see that what happened. So till that time we will just go on the top, we'll use the account admin, and I will explain you about this task history table. So basically whatever task statement is doing, like, so when you create a task, it's keep on executing on every interval of every 1 minute, right? So it's a scheduler, it just keep on executing. So whenever it get executed, it insert a record into a task history table. So basically this task history table is being kept on the Snowflake database, which is a shared database on the account users schema. So if you query this table, you will not see any data unless there is a single execution on the table. So this query takes some time to reflect, maybe because I'm using the smallest compute. Maybe that is the reason, or I'm not sure about the reason, but my experience is like it takes almost 1 minute when I use the extra small compute. So let's wait for the output of this query, and then we will see whether we see any kind of a data on the task history, and if whether that statement is successful or failed, or what is there. So if it ran successfully, you will see one single record with successful execution. So let's see. I think by the time this query will give the output, we will see the data on the directly on the table. So let's abort this. I'm not sure it will take much time. So let's go and see the employee audit history table. So now that you can see that all the statement is populated on the audit history, we don't need to look into the history table, but all the data is already there on the audit history table, and stream is going to be blank, right? So now we don't see any data on the employee audit history table. The same thing if we now that we know that task is keep on running as a schedule on every 1 minute, let's quickly execute the delete statement and see the stream. So let's see, if we go on the standard stream, we will see one delete statement, right? And if we update the ID 5 with the name Rajiv, we will see 2 more records on the standard stream. So now as finally we will see 3 records. So now we will see only 2 records because I think we have already consumed. So if we execute one more time, we will see we will not see any data. Okay, so if we go and see the employee audit history, we see only 5 rows. I'm not sure whether let me see on the employee table itself first, the data part. I think I'm missing something. Okay, we have updated also. So that means we should see, okay, we only see the update record for insert and delete, and id equal to 1. I think we have already deleted the one id, or what. Okay, we don't have any id called 1, that's the reason we don't see anything. Let's delete id number 2. So let me modify this with 2, and let's delete this record so that we will see only 3 records on the string. So now we will see, because 2 has already been consumed, we only see id number 2 as a delete statement. So it will also get consumed in another minute. So let's execute the employee audit history and see whether we see those data. So now that you can see that we have updated the id number 5. So if I modify, I mean like order by or sort this table with the id column, we will see that for id number 5, you will see that updated record was Rajiv with an insert, and the old record was Pinus, right? So the name of the employee was Pinus, and the revision was with -2, because if it's an update, we are going to use the current version, which was 0, -1 means actually it will be -1. And in case of delete, if you see, it will be delete and the revision is 999. So hopefully we will see still the data. No, there is no data. Let me requery and see. So now that we have already deleted ID2, we are seeing here as ID2 with record version 2, and all the timestamp and also been tracked here, which give you a information, quite informative information, what kind of action has been taken on the your parent table or the source table, and what was the changes. And you can easily, based on the revision, you can sort and identify and make more information out of this base information. So now that we have already executed and seen how we can use the stream along with task as a automated process to keep track of your source table. So hope you like this demo. So now we have already done everything. We have, it's a good idea to suspend your task, because if it's keep on running, it will cost you money. So I'm going to suspend my task. So how you can suspend, you have to go on the account admin if you don't have those privilege, and then alter the task and then suspend. So I suspended the task. Now if I go and do the show task here, you will see that it is still on the suspended mode, right? So now everything is done, so I don't need this database anymore. I'm going to do the cleanup. I'm going to delete everything. So hopefully you like my demo, and if you like my demo, please subscribe to my channel. Thank you.